So in today's class we'll start with a topic called phenol. What are phenols as it is written on the blackboard? It is the group of compounds in which OH is directly on the benzene ring. Phenol is known for its antiseptic property. The simplest member that is there is in the blackboard, benzene with OH. It's called phenol. It has got acidic nature. Its common name is carbolic acid. It is having acidic nature. It's much stronger acid as compared to alcohol. When you go to the hospital and you get a peculiar smell of an antiseptic, it is of phenol. So phenol is a very good compound. It is known for its antiseptic property. It is also used to make an important drug called aspirin. Later on we'll do the preparation of aspirin also. So as such, what are phenols? Just to revise, it is OH directly attached to the benzene ring. Like for example, this compound cannot be called phenol. This is benzyl alcohol, but we can't call it as phenol. Any guesses why this is benzyl alcohol and not a phenol? Because as I told you the definition, what is phenol? Phenol is nothing but OH directly attached to the benzene. Now let us see some more derivatives of phenol. Let us put OH group, two OH groups on the benzene ring. We've got three isomers. We can have benzene. We can have OH at this position and this position ortho. This compound is commonly called as catechol. It's called catechol. We can have at the meta position. We can have benzene. And the OH groups at the meta position. This compound is commonly called as resorcinol. Resorcinol. And we can have the last one, that is a para one, in which it's like this. This is commonly called as nothing but hydroquinone, or simply called as quinone. Can you try giving IUPAC name of these three compounds? The first one, as you can see, the two OH groups are one at 1, another one at 2. This can be called as benzene 1,2 diol. Second one, what can be the IUPAC name? Can you guess? It will be benzene 1,3 diol. Diol means two alcoholic groups, commonly called as resorcinol. And the last one will be benzene 1,4 diol. Now this is an NCERT question given at the back. They are given as a molecular formula C7H8O. This is the molecular formula. We have to draw three isomeric phenols. So the three isomeric phenols that we can draw is one like this: benzene, OH, having a CH3 group at the ortho position. Second one in which the CH3 is at the meta position. The last one at which we have CH3 at the para position. All the three are commonly called as cresols. So this will be called orthocresol. Ortho means 1, 2. This will be called metacresol. Vodacresol, in which benzene has got OH group as well as CH3. That's a common name. This will be paracresol. So we've got three isomers: ortho, meta, para, cresols. What will be the IUPAC name? Can you try yourself? The first one, orthocresol. What will be the name? The numbering will start from the OH group 1, 2, 2-methylphenol. Next one, metacresol. What will be the IUPAC name? It will be 3-methylphenol. Next one, it will be 4-methylphenol. So as such, what are phenols? Phenols are nothing but group of compounds in which OH directly attached to the benzene ring. If OH is directly on the benzene ring, it will modify the property of the molecule. There will be a property possible called resonance. So resonance will modify the properties of phenol. Now today we will also see the preparation of phenol. We can make phenol from the following three compounds. The three compounds by which we can make phenol is as follows. We'll be making phenol from the compound called chlorobenzene. We'll convert chlorobenzene to phenol. We will convert aniline into phenol. Remember aniline, benzene with NH2. Benzene amine, the common name is aniline, and we'll also convert benzene into phenol. So these are the three compounds by which we are going to make phenol. Chlorobenzene, aniline. What is aniline? NH2 on benzene, right? And third compound will do it from benzene. So let us do the first method of converting chlorobenzene to phenol. Let's see how we can convert chlorobenzene to phenol. The name of the process is called Dow's process, by which we can convert chlorobenzene to phenol. We want to convert chlorobenzene into phenol. It is a simple nucleophilic substitution reaction. It's a simple nucleophilic substitution reaction. We have got chlorobenzene. What we want to do is replace Cl with the OH group. So what we do is that we reacted with aqueous NaOH. You will find chlorobenzene, if you put aqueous NaOH at room temperature, this OH cannot replace Cl. Can you guess why? Why Cl cannot be replaced by OH at room temperature? The reason is very simple. In this molecule, there is a possibility of resonance. Due to resonance, this bond, the carbon-chlorine bond, is not a single bond. It has a partial double bond character, stronger than single bond. So at room temperature, this carbon-chlorine bond will not break and will not be replaced by the nucleophile OH minus coming from NaOH. So we need to do this reaction at high temperature, 623 Kelvin, and a very high pressure of 300 atmosphere. Drastic condition. Under drastic condition, what is going to happen? This carbon-chlorine bond will break and the Cl will be replaced by OH. So you will get the formation of phenol. But there will be a problem. Phenol will be formed. As I told you a few minutes back, phenol is an acidic compound. So as phenol which is formed is an acidic compound, you are working in a basic medium, you use NaOH. Phenol is going to react with unreacted NaOH and will convert into its salt. Phenol will be formed, but it can react with the unreacted NaOH and form the salt. This salt is called sodium phenoxide. So in the first step, you won't get a phenol, you will get a sodium salt of phenol. It is only when you do acidification of the medium, we will get the formation of phenol. So this is how we can convert chlorobenzene into phenol. The name of the reaction is called Dow's process. It is an example of simple nucleophilic substitution reaction. Cl minus replaced by OH minus. Cl minus a nucleophile replaced by another nucleophile, OH minus, coming from NaOH. And why the reaction is to be done under such high temperature, high pressure? Because we have to break this carbon-chlorine bond, which due to resonance has got the partial double bond character. So this was the first method of converting chlorobenzene to phenol. Now let us see the second method of converting aniline into phenol. As I told you, what is aniline? Aniline is nothing but benzene with NH2. So let's convert aniline into phenol. Aniline cannot be converted straight away into phenol. Aniline has to be converted into a very important synthetically useful compound called diazonium salt. So what we do is that first of all, aniline is subject to a process called diazotization reaction. We do diazotization reaction in which we'll convert aniline to diazonium salt. How do we do it? We react aniline with sodium nitrite NaCl. Temperature has to be around 0 degree to 5 degrees Celsius. Aniline will convert into diazonium salt. It is benzene with N triple bond N Cl minus. This compound is synthetically a very useful compound called benzene diazonium chloride. Benzene diazonium chloride. After this is formed, you subject it to hydrolysis. And when you do hydrolysis, it will convert into phenol. So this is how we convert aniline into phenol via diazonium salt. Via diazonium salt. We can convert aniline into diazonium salt. into phenol. So this was the second method of benzene into phenol. First one was chlorobenzene into phenol. The name of the process was called Dawes process. Now we are going to convert benzene into phenol. We take benzene. So first of all, we are going to do its sulfonation. Remember sulfonation, an example of electrophilic substitution reaction. So react with compound H2SO4. We will get benzene with SO3H. We get benzene sulfonic acid. This compound is called benzene sulfonic acid. Benzene sulfonic acid. This is nothing but an electrophilic substitution reaction. Then in the next step, we make it salt, sodium salt. We react with NaOH. You will get a sodium salt of benzene sulfonic acid. Hydrogen will be replaced by Na. You will get SO3Na. This salt is called sodium benzene sulfonate. Sodium benzene sulfonate. The sodium salt of benzene sulfonic acid. This salt is heated strongly with solid NaOH. Heating solids together, the process is called fusion. So we fuse sodium benzene sulfonate with solid NaOH, heated very, very strongly. It decomposes to give you phenol. But same thing, because phenol is acidic. As soon as phenol is formed, it will react with unreacted NaOH and convert into a salt, that is sodium phenoxide. So in the first place, you will not get phenol, you will get sodium salt of phenol, sodium phenoxide. How it is being formed? Phenol that is formed immediately reacts with unreacted NaOH to form a salt. It is only when you acidify the medium, you will get the formation of phenol. So this is how we can convert benzene into phenol via sulfonation. So first step, as I repeat, benzene is subject to electrophilic substitution reaction. That is sulfonation, you get benzene sulfonic acid. Then you react it with NaOH to form a salt of benzene sulfonic acid, that is called sodium benzene sulfonate. It is a solid compound. It is heated with another solid, that is NaOH, very strongly. Heating two solids together is nothing but called fusion. So you fuse sodium benzene sulfonate with NaOH, you get a salt of phenol called sodium phenoxide, which on acidification will give you nothing but the formation of phenol. So these are the three methods of preparation of phenol that we discussed. Number one was from chlorobenzene, second one was from aniline, and this was the third one from benzene. Lastly, we are going to discuss one of the commercial method of making phenol. Commercial means on the large scale. Why do we need phenol on a large scale? Because of its antiseptic property, and it is used to make an important drug, as I told you, aspirin. Any guesses what's the use of aspirin? It relieves pain as well as brings down the body temperature. The pain relieving drugs are called analgesics, and the one which brings down the fever is called antipyretics. So phenol is aspirin is a drug which can act as an analgesic as well as antipyretic. So we are discussing the commercial method for making phenol. The name of the process is called cumene process. It's called cumene process, the commercial method of making phenol. So what we do is that we take benzene, we subject it to a Friedel-Crafts reaction with propene. It's a Friedel-Crafts reaction, basically a alkylation. In the presence of an acid, like acid we can take is phosphoric acid. What is going to happen in the first step? Propene will attach to the benzene by middle carbon. This is nothing but simple Friedel-Crafts alkylation. The compound we are going to get is called cumene. This compound is commonly called as cumene. This compound is commonly called as cumene. We can also call it as isopropyl benzene. Isopropyl benzene. So the first step is Friedel-Crafts alkylation of benzene with propene. Then we subject it to oxidation with air which contains oxygen. So we oxidize cumene with oxygen. Oxygen is going to add up over here between this carbon and this hydrogen. So you get an oxidized product. Cumene gets oxidized. Between C and H, two oxygen will add up. Like this. This oxidized product is called cumene hydroperoxide. It's called cumene hydroperoxide. Cumene is oxidized by atmospheric oxygen. So first step was Friedel-Crafts alkylation with propene of benzene. We get cumene, which is also called isopropyl benzene. It oxidizes with air, which contains oxygen. You get cumene hydroperoxide, and when you hydrolyze it, this compound on hydrolysis will give you a commercially important compound on a large scale. It's a commercial method to make phenol. And the other commercially important product that you're going to get will be none other than your acetone, which you know is used for nail polish remover. This is acetone. Nail polish remover as well as used to remove stain. So in today's class, what we have discussed is what are phenols. What are phenols in which OH is directly on the benzene ring. Next, what we have discussed in today's class was the preparation of phenol. We have done 3 preparation of phenol. The lab preparation, one was from chlorobenzene to phenol, it was a Dow's process. Second one was from aniline. First of all, we convert aniline into diazonium salt, hydrolyzed to give you phenol. The third one was from benzene to phenol via sulfurization. And the last method is still there on the blackboard. The process is called cumene process. This is commercial method to make phenol. And just to reinforce, why do you want to make phenol commercially? Because it's known for its antiseptic property. And with the help of phenol, we are going to make an important drug called aspirin. What are the 2 uses of aspirin which I have told you? It is used for pain relieving and bringing down the body temperature. It acts as an analgesic, pain reliever, as well as antipyretic, which brings down the body temperature. So that's all for today's class. Tomorrow we'll discuss physical properties of phenol and few chemical properties of phenol. Remember, phenol is acidic in nature, more acidic as compared to alcohols. Thank you. Have a nice day. Take care.